So we know the difference between discrete, that's the whole number, countable. How many books you have, how many gas stations there are, how many pumps there are at a gas station. The amount of gas in the gas station is continuous. If you can ask yourself if it has a half or a 0.5 or a 0.1, then it's continuous. And make sure you know these two criteria. This is what gives you a probability distribution function. This is different than your frequency distribution. Frequency distribution, we start with that, and then we build our probabilities like that. So probabilities have to be between 0 and 1, and have to add up to 1. So we were asked to check the tables, and we said, this one first, yes, our probabilities were between 0 and 1, and they added up to 1. This guy, right away we can spot this one, even though they use different denominators, that's okay. Still the same rules. If any individual probability is not between 0 and 1, such as this one, it's not a probability distribution. If that one was, we would just have to put all those fractions in your calculator to make sure they added up to 1. We can have different denominators, which is why I like to flip the probabilities to decimals in the long run when we work with them. Find the mean, the variance, and the standard deviation. Everybody can do this. Put it in your L1, L2. Okay. You can even use your n times p if they gave you a probability, but in this case they didn't give you anything else but this table. So we're going to put this in your L1, L2. Remember, because that your sum is 1, you have no sample standard deviation. Okay? Because your sample standard deviation, we do n minus 1. And if our n adds up to 1, we can't divide by 0. So you're just getting a population standard deviation. And everybody can find it in the variance thing and then square it? Okay. And they ask you to interpret. The interpret just means, when I get a mean of 2.8, what the heck does 2.8 cell phones mean to me? It means that the average number of cell phones per household is about 3. It's close to 3. Okay, the standard deviation we know, and the variance really doesn't mean as much to us right now. The standard deviation will start meaning a little bit more to us pretty soon. So they're within 1, plus or minus 1 of each other, kind of. Yes? I'm sorry, it's missing a battery? No, I'm getting a lot of these that's missing one battery. People are police. Yeah. Yeah. But they're taking one battery out of all these calculators. Let me shut the thing up and tell you my take on this. Yes, it sounds very old. So, I didn't think you guys had those CD players. All right. This was a little confusing as it stood. And this should say a half. This should say a half, not a quarter. If you did this, there's 2 ways to do this. I took one of them out, and I forgot to change my thing. You could do this with the 0 and 1/4, or you can just do it with the 0 and 1/2. Either way you did that. 0 and 1/4 or 0 and 1/2 is fine, because you just kind of combine those. That meant that had no value. You had a wash. Don't forget, this part here is net gain. This row across here. This is your gain. Your gain, and this guy happens to be your loss. You didn't have a gain. You had a loss when you didn't win anything at all. So 1/8 of the time, even though you won $125, you lost your $25 that you bet, so you gained $100. Here you washed. You bet 25, you won 25. So your net gain was 0. And then here you didn't win. So whether you left it as 1/4 or 0 1/2 is fine. A good way to find this is just take these guys and just add them together, subtract them from 1. That's your complement case. Everything but those. So that's your complement case. Okay? And you can kind of come up with your, you could do it one of 2 ways. The way we normally say to do it is x times p of x Multiply this times this, this times this, this times this, and then take the sum of these guys. This is the same as your mean. So if you want to put this in your L1, put this in your L2, you're going to come out with the same answer. Right now your mean is your expected value. We don't weight anything differently. Well, they'll tell us what it is. They'll tell us what it is. They'll always give us what we have to do. Okay? And 10 was a little trickier. I wasn't fond of the way they set up 10, so originally I wasn't going to give it to you guys, and then I decided to do it. They gave you this. This is not your gains and loss. This is your prize list. This was a prize list. So from here, you had to set this row up. This is your gain and loss. So be careful. They wanted us to make a chart on our own by their prize list. So each ticket cost you $5. There was only one winner for the $100,000. But if you won, you had to take away your $5. The 100 one had a 1 in 100 chance of winning, but you still won $95. The 45, well, the $50 had a 1 in 50 chance, which is not so bad to win, but you won $45, and everybody else was a loser. So this is the 1 minus situation. If you add up all those parts, you get this guy right here. And again, if you want to do x times p of x and take the sum of that, that will work. Or this is your mean. Put this in your L1, L2. Just make sure you put the negative number in there also, or you're going to have a really high expected gain. So we're okay with that? So this is what we expect to lose with each ticket that we buy. That's what this is telling you over the course of time. Are we good with this? This one was a little confusing the way they first set it up. But just so that you can kind of get that part. For this one, you just had to tell me if it was a binomial or not. The probability stays fixed. We do it n amount of times. We either get a, what are we looking for, a blue or not a blue. Bless you. So you have two choices. One's a success, one's a failure. We did it X amount of times. Our random variable says from 0 blues to 12 blues. So yes, this was a binomial. Okay. And then this one, you had to make a chart. From there, you had to take, once you make your chart, is everybody okay with making this chart? Again, binomial PDF. This is NPX. It's in alphabetical order. The number of trials, probability of success, and then let this one go from 0 to 9. If you do the C, you're going to start it like this. Probability of success. You wanted 0. Probability of failure, this is where you need your failure. You wanted 9. Each time through, you're going to change this one, this one, this one. And you can absolutely run that all the way through.
So
Yeah.
For the last one, I know that it was in like scientific notation. Can we leave it in scientific notation in the chart?
Well, the problem is this. If you leave it in scientific notation, and then they tell you from like 7 or more, as long as you remember to change it so that you could add it in. Yeah, I mean, if it's got a lot of zeros, definitely leave it in scientific notation. But if it's only a few, I'd write it out. Because if they say, like, what's the probability of 7 or more, you got to be able to add this guy in there. All right, now, based on your chart, you can answer these questions. Based on your chart, I want exactly 5. I come to my 5, there's my exactly 5. I want at least 5. That's the least it could be. So I'm going to add up my 5 or more. That's when you really want to leave that one out. I want more than 5. So why is that different than at least 5? It doesn't include 5. But my more than 5 says, well, I got 6, 7, 8, 9. These are all mutually exclusive of each other. You can't be in one category and be in another category. So you can do your ads, that's your or. You can do your ads straight through. Okay, once you build the chart, and when you take the test also, I need to see what you add up. I realize you can just sit there with your calculator, but I need to see what you add up to get it. Also, if you forgot to add one section, and I just get a total, your total is wrong. I don't see what you did. If you did 5 or greater, and you weren't supposed to include 5, at least I can give you part credit. But if you only give me an answer and the answer is wrong, I need to see where your answer comes from. Are you guys okay with this? Nick, are you okay with this? Okay, so you can do binomial PDF? Okay. Everybody can do that part? All right, good. Oh, that's weird. Okay. Another one, we just did another one. We did a couple of them. 38% of employed wives in the U.S. earn more than their husbands. You randomly select 5, there's your N, and ask them whether they earn more than their husbands. They say yes or no. Success or failure. Now remember, your success or failure is based on your scenario. 38% is not more than 50, I realize, but it is the success of this scenario. So you're going to set up your table, 0 through 5. They ask for a graph for this. Remember, your graphs need a title. The x-axis is all the x values. Your y-axis is your probability. So you found your probability using your binomials, or Bernoulli's with a C. And we find this is slightly skewed to the right. And we know it's skewed to the right because my probability is smaller than 50%. 50% would give me a symmetric curve. If it's skewed to the right, if it's less than 50%, that means I expect more people to say no than I do to say yes. My probability isn't as great. This is typical of what you might see tomorrow. So we can all do this, right? And I was really surprised to see that that probability was so high. I'm happy to see that high.
How do you know if it's unusual?
If it's unusual, if it's less than 5%. Our baseline has been the same. If it's something is unusual, it's falling less than 5%. So your 5 would be less than 5%. Okay. The last one, 63% of U.S. mothers of school-age children choose fast food as a dining option for their families 1 to 3 times a week. That I find is very high. You randomly select 5 U.S. mothers with school-age children and ask them if that's what they do. Choose it 1 to 3 times a week. The 1 to 3 does not have any bearing on your probability. It's just that's the scenario part. So your random variable is from 0 to 5. Now, they just wanted your average, your mean, your standard deviation, and your variance. You can also set up a table if you feel more comfortable because it's only 0 to 5. If it was 50 women, you definitely wouldn't want to set up a table for 50 women and do L1, L2 after doing all your binomials. So we have these nice little rules, formulas, that you have to remember, okay, to be able to find this. Now, I find the mean makes common sense because if you have an amount of people and your probability is, say, 20% that those people are going to say yes, 20% times n makes perfect sense, right? So there's your n times p. Then your next step is multiply by q. Then your next step is take the square root. So it kind of falls into place. And on the average, 3.2 mothers, so you're going to say about 3 mothers out of 5 choose a fast food option for their families 1 to 3 times a week. Yes?
So you use you and those occasions for any specific?
whenever you want to find the mean, the standard deviation, and the variance, you use those. You could also have set up a table if you wanted to. And did your binomial PDF thing, set up this table, and then did this L1, L2. That would work too. But you got to find your binomial PDF for each one of these. This is your probability. Once you set up your probability, you can put this in your L1, L2. They only asked you for 5. If they asked you for 50, you definitely don't want to do this route. You just want to use those formulas. And those formulas work as long as they're not asking you for any of this that you need. You just need to throw those in there. Okay? And this was your review. You guys have it.